So that was as I was telling, sine inverse x plus cos inverse x is pi by 2. Since differential of sine inverse x is 1 upon square root of 1 minus x square, so differential of cos inverse x is differential of this identity, since cos inverse x will be pi by 2 minus sine inverse x. So you will be here, and differential of cos inverse x is this. Same way, if differential of tan inverse x we prove according to the previous method, then differential of cot inverse x will be minus 1 upon 1 plus x square. And differential of, if we establish sec inverse x as 1 upon x under root x square minus 1, then differential of cosec inverse x will be minus 1 upon x under root x square minus 1. These are the basic formulas, and once again I will explain how these all 6 formulas are coming. So these are the differential of 6 inverse trigonometric functions. You can see this one. 1, 2, 3, 4, 5 and 6. For example, I have to establish once again, suppose differential of tan inverse x. See how it happens. Now to explain the differential of y equals to tan inverse x with respect to first principle method. Suppose it is any position along the curve at the point x, y, then in its neighborhood y plus delta y will be tan inverse x plus delta x. Now when we go for the first principle method, then we write this formula delta y, dy dx equals to limit delta x is tending to 0, delta y upon delta x. Now this formula is written when y is the function of x. What is the meaning? That means here we observe the change in y when change is made in x. The change of y experienced in y with respect to when x is changed. It is done because y is the function of x. But since suppose we don't know directly to find the differential of this, so we write this as x as function of y. Then x plus delta x will be function of tan y plus delta y. Now from here this is coming, and from here this is coming. So since for this, when y is the function of x, then this formula is used. Here you are seeing x as looking as a function of y. So what we write? We have to write change in x due to change in y. Then how the same formula, this formula is brought on this format. dy dx, we bring delta y below, delta x. How? Delta y upon delta x. Since this time delta x is below, then we make limit one upon delta x, delta y, and here we write limit delta y is tending to 0. Alright, so for this structure we have dy dx. So for there was delta y above and delta x below. Here delta x is above and delta y is below. So we may write this entire structure as dx dy. That means differential of y with respect to x is nothing but reciprocal of differential of x with respect to y. This concept will also help us in case of differentiation of implicit functions. Now, what was x? X was this. X was 10y. So it is sec square y. But our differential, since y is with respect to x and initially the y was a function of x, so we should get the differential also in x. So we write this as 1 plus 10 square y, and 10y is nothing but x. So it is 1 plus x square. So you can say that dy dx, that means what was y? Y was 10 inverse x is nothing but 1 upon 1 plus x square. That was a way to prove differential of 10 inverse x with respect to x. That's our formula to prove this. Alright. Now, for the established concepts of differentiation of inverse trigonometric functions, now we will be solving the questions of exercise 5.7 of your textbook. So I am seeing there are few questions. For example, we have second, third part, which is y equals to root of sine inverse 2x. Since it is a composite function where y is a function of square root, inside square root there is sine inverse, and sine inverse is a function of 2x. So we should apply here chain rule. Suppose d dx is a differential operator. So first it strikes to y. Then it becomes dy dx. Next, this this red arrow is nothing but representing the differential operator d dx. Now it will travel across as equal sign and it will reach to next side. It will strike to root. Assuming inside there is x, it will assume this as a root x on this side. It will differentiate into 1 upon 2 root x like this. But there is no x. Instead of x, there is a full-fledged function. So we write sine inverse 2x. Then after this, arrow reaches to sine inverse. Assuming this part as x, so sine inverse x differential we have just seen in the same lecture, that is 1 upon under root 1 minus x square. So assuming 2x as x, it will differentiate into 1 minus x square, but instead of x there is 2x. Now this arrow being differential operator will be reaching here in the end at 2x, and it will differentiate 2x into 2. Now later you can simplify this by cancelling, and this equals to 1 upon under root sine inverse 2x into 1 upon under root 1 minus 4x square. That is the way to solve this question. Now we take another question. Second question, fourth part, where y equals to sine 10 inverse x. Immediately after seeing this question, one gets an idea that they should start solving with the help of chain rule of differentiation. But I will suggest you, whenever in any question there is a trigonometric function as well as inverse trigonometric functions, you should try to apply this approach in any form under the limits of the domain, that means limits of the value x. So they neutralize each other. Here x is an angle and they neutralize each other. Here x is a value. So here x has a value, being in an angle from minus pi by 2 to pi by 2, and here x being a value, here x belongs to minus 1 to plus 1. So if outside we can't do anything, if inside we are able to change this into sine inverse x. So as I have told you in my classes that you can change into by the law of conversions. It is x upon 1 under root 1 plus x square. So it is sine inverse x upon under root 1 plus x square by the law of conversion. So it becomes x under root 1 plus x square. So here we have not differentiated, we have just now simplified this function. Now here you can go for the differentiation of this function, like dy dx is, you can apply the quotient rule, root 1 plus x square whole square, root 1 plus x square differential of x, and minus x differential of root 1 plus x square. See, further, if you are not understanding, you may be feeling I am writing in fast speed because we have to cover a video in limited time. So you may rewind it, you can see from the beginning, that is very suitable, which is not possible in the classes. So from here I am writing from in the top. dy dx is, it is 1 plus x square, root 1 plus x square into 1, differential of x with respect to x is 1, x into differential of this function is 1 upon 2 root 1 plus x square with 0 plus 2x. Now further, now is a rule of algebraic terms are left. This being a LCM is multiplied here, and it is x into x is minus x square, and this also being an LCM is multiplied here as 3 by 2. It get cancelled, so you get 1 upon 1 plus x squared to the power 3 by 2. That is the answer of this question which we were solving. That was question number 2nd. Fourth part, differential of sine tan inverse x. Alright, that is the answer of this question. Further, if I take from the same exercise 5.7, question number 3rd, first part, as y equals to sec inverse cosec x. So I will suggest you, instead of making a hurry for applying chain rule of differentiation, better you solve, because these two are in opposite format. Here is an inverse trigonometric term, here is a normal trigonometric term. So if we are able to bring sec format inside, then they may be neutralized. So it is, sec inverse and sec inverse sec pi by 2 minus x. Both will be neutralized. It is pi by 2 minus x, y. Then on differential of this, it is nothing but minus 1. You may think that if somebody is doing directly, however, he may get the answer, but it will take many more steps and will waste the time of the student. That is the answer. So further, next question number 4th, second part, where it is given y equals to sine inverse x, sec inverse 1 upon x. So you may write this as sine inverse x with cos inverse x, which is pi by 2, whose differential is nothing but 0. So question number 1 to question number 5, there are usual questions to memorize the formulas. Now after this we will be starting from question number 6. What is question number 6? Sixth question. First part, it is y equals to x tan inverse x. Since there are two functions, then dy dx is x is as it is, differential of tan inverse x as 1 upon 1 plus x square. Then tan inverse x is as it is and differential of x is 1. So this is going to be x upon 1 plus x square with tan inverse x. That is the answer of this question. Now I would like to solve question number 7 from same exercise, that part 1. Y equals to cos inverse 1 minus x 1 plus x. You can solve this in many ways. First you can go it directly like dy dx. Now you come here, cos inverse, instead of x there is 1 minus x 1 plus x. Formula is under root 1 minus x square. You know, d dx of cos inverse x is minus 1 upon under root 1 minus x square. But there is no x, instead of x there is 1 plus x. Then next you reach here, you have to apply the quotient rule. 1 plus x, denominator whole square, denominator function, differential of numerator, numerator function, and differential of denominator function. Now further when you simplify this, you know, it will be 1 plus x as 1 plus x whole square with 1 minus x whole square. And it is nothing but minus, it is minus 1 minus x minus 1 plus x upon 1 plus x whole square. So x goes from here, minus 1 is minus 2, minus minus is plus 2 times 1 power of this is cancelled. So nothing is left here. 1 upon 1 plus x under root. When you simplify inside, it is nothing but 4x. That is going to be 4x. Here when you simplify this, 1 plus x whole square 1 minus x whole square is going to be 4x. So square root of 4 will be 2. 2 get cancelled from here. Then it is 1 plus x and root x. That was the answer of this question, dy dx. Another way I will be telling you. So I was telling another method of question number 7, first part, for y equals to cos inverse 1 minus x 1 plus x. You can use trigonometric transformation as we have discussed in the chapter of inverse trigonometric functions, where you can put x as tan square theta. So y equals to cos inverse 1 minus tan square theta 1 plus tan square theta cos inverse cos 2 theta, and since they neutralize each other, it becomes 2 theta. But we have to bring theta in terms of x from here. So tan theta is root x and theta is tan inverse root x. So you may write here 2 tan inverse root x. Now finally you have simplified function of tan inverse root x. Here you can apply the chain rule of differentiation. That means dy dx, to you reaches here, it is taken as an x 1 upon 1 plus root x whole square. Then you reach here, it is 1 upon 2 root x. 2 get cancelled. So your answer is 1 plus x with root x. Same as we got in previous session for the same question. So any way you can do that, it depends on your choice. Okay. Further, one more question I want to bring. in this discussion. Question number 8, first part, y equals to sine inverse x with sine inverse under root 1 minus x square. This will be my advice to all the students. Before differentiating any function having inverse trigonometric terms, first try to simplify them. You just try to see if there is some easier term to solve this problem or not. For example, if somebody is doing it directly, then he will be differentiating them separately. Here direct formula, here he has to apply the chain rule of differentiation. At least it will take 4 or 5 steps. Rather than doing that way, I will suggest you to recall in your memory the related formula. It is nothing but from the convergence formula, it is cos inverse x. So it is pi by 2. So you can say that here differential is nothing but 0. Now you can understand it is a single line solution, but somebody who is doing it directly with the help of chain rule of differentiation will get the same answer in 3 or 4 or 5 steps. So better, before differentiating inverse trigonometric function, first try to simplify them for some simpler form. Now coming on other questions of the same exercise, suppose I take 9th second part. And this question, probably if you remember that I've explained in inverse trigonometric functions, sine inverse upon 1 plus cos x. Assume somebody is solving it directly, differentiating this directly, applying the chain rule of differentiation. Then what happens? Then he has to first differentiate tan inverse, assuming this as an x. Then he is going inside for this bracket and he gets the rational form of the function, numerator and denominator, and he is you may just understand that there are so many steps. So that's why I'll suggest you, if there is an inverse trigonometric functions and outside inverse format, inside normal format of trigonometry, you would like to solve them for some easier simplified term. So that is, you reduce them into the corresponding formula, like sin x by the half angle formula is, and 1 plus cos x is nothing but 2 cos square x upon 2. 2 get cancelled, cos x is cancelled. So it is nothing but tan inverse, single sine is left, single cos is left, tan x upon 2. So since they both neutralize each other, it becomes x upon 2. Now we have finally y equals to x upon 2. Oh, that's very easy to differentiate. Dy dx is half. Now you may understand the person who is not doing this way, doing it directly, he will get the same answer. I don't have any doubt on the capacity of the students, of their algebraic skills, but they will take so many steps to get this answer. So my advice for the board students, because in a board classes, board examinations are quite different from the competitive examination, where in board examination we require to score full marks in mathematics, that means 100 out of 100. For that, you need to limit yourself up to the few steps of the solution, which is according to the marks assigned to the question. If it is 2 marks question, then you should write in 2, 3 or 4 lines. If it is 4 mark solution, you should write 4 to 8 lines. But somebody is going beyond this, he is just wasting the time and paying the cost of other questions. Similarly, another example, another question from the exercise 9th second part. Y equals to tan inverse under root 1 minus cos x, 1 plus cos x. Once again, simplifying this before differential, you know this is the formula of tan square x by 2, tan inverse tan x upon 2, and that is going to be x upon 2. Same, dy dx is nothing but half. That is your answer. Another question I want to explain, question number 11. First part, y equals to sine inverse x upon under root 1 minus x square. Then prove that 1 minus x square dy dx minus xy equals to 1. Solution. Differentiated directly by the quotient rule. 1 minus x square root whole square root 1 minus x square differential of numerator function minus sine inverse of x differential of 1 upon 2 root 1 minus x square and minus 2x. You see what happens? 2 get cancelled, and here it is 1 minus x square. This is being an LCM, reaches here. Same time it is these two are cancelled also. Alright. So, or another way, you may simplify in this way also. 1 minus plus x sine inverse x root 1 minus x square. I'm sorry, because of square root, the root symbol will go. And here it is under root 1 minus x square. It is 1 minus plus x sine inverse x under root 1 minus x square with 1 minus x square with dy dx. Now 1 minus x is cross multiplied here. 1 minus x square dy dx, and it is 1 plus, you write this as x into sine inverse x under root 1 minus x square. This is nothing but the function itself. This is nothing but function itself. So 1 minus x square dy dx equals to 1 plus xy. Further, you can bring this term on this side. So 1 minus x square dy dx minus xy equals to 1. That is the answer of your question.